Assalamu alaikum kids. Inshallah, in this video we'll talk about the motion of a parachutist. Now the motion of a parachutist is interesting because as your parachutist falls, they reach terminal velocity eventually when air resistance catches up with weight. At that point, the resultant or the net force on an object becomes 0 newtons and it falls with a constant speed known as the terminal velocity. Now, this concept right here essentially tells us on how to reduce the terminal velocity drastically so that even a person falling from air can land safely. The journey of a parachutist begins when they jump off a plane. We are going to describe the journey of the parachute with a velocity time graph. Initially, the parachutist is considered to be at rest even though they are in a plane which is moving. The vertical velocity of the parachutist is considered 0. Hence, the velocity time graph starts from the origin right here. The acceleration is constant at 10 meters per second squared. Hence, we have a straight diagonal line which represents constant acceleration. As the parachutist falls, the parachutist gains speed. An increasing speed results in an increase in air resistance, and an increase in air resistance decreases the total resultant force on the parachutist. A decrease in the resultant force results in a decrease in acceleration because acceleration is directly proportional to force. We can observe that on the velocity time graph as a decrease in gradient of the parachutist. A decrease in gradient of the velocity time graph means that the acceleration is also decreasing. When the total upward force and the total downward force become equal to each other, the resultant force on the parachutist becomes 0. When the resultant force is 0, the acceleration of the parachutist also becomes 0, and at this point, your parachutist will no longer accelerate and will continue to fall at a constant speed, which is known as the terminal velocity. Now we can observe the constant speed on the velocity time graph as a straight horizontal line. As the parachutist approaches the surface, the parachutist will now deploy the chute. When the chute has been deployed, the area of the parachutist increases drastically, and as the area increases, your air resistance increases as well. Now your air resistance is much larger than the weight, so your net force is upwards. That causes a decrease in speed of the parachutist, which we can see the velocity time graph goes down. As the velocity time graph goes down, we can see that the velocity is decreasing. And at this point right here, again, the air resistance and the weight of the parachutist have balanced each other out. And the parachutist will continue at a new, much lower terminal velocity and will touch down safely. Now, it's very important to understand this graph and to be able to explain every feature of the graph. That's why I've decided to break the graph into 5 separate parts. The first part is where the parachutist is accelerating at 10 meters per second squared. The second part is where the air resistance has increased sufficiently to decrease the total resultant force, the net resultant force, and the parachutist is now moving with decreasing acceleration. Your velocity is still increasing. Your graph is going up, means the velocity is still increasing, but the rate at which the velocity is increasing, that decreases, or in other words, we can say that the acceleration is decreasing. Part 3 is where your acceleration is now essentially 0. Your total upward force, the air resistance, and your total downward force, the weight, are now equal to each other. The parachutist has now achieved terminal velocity. The fourth part is where the chute is deployed. Your surface area increases drastically, increasing air resistance. That decreases the speed of the parachutist. We can see the decrease in the velocity time graph to the point where it reaches right here. This is part 5, where the parachutist is now continuing to fall, but this time, because of the parachute, your terminal velocity achieved is much smaller, and the parachutist can now land safely on the ground. That is it for this video, kids. Inshallah, I'll see you in the next one. Bars out.